Hi, and welcome to episode 3 of Modulus Manufacturing's build of the Pinion Robotics AR4 Mk3 Robotic Arm. In this episode, we're starting at the end of the robot arm that is, with the AR4 Servo Gripper Kit. This gripper, which I'm holding, uses a 25 kilogram servo and a number of 3D printed components to provide the robot arm with the ability to grab objects using a servo motor. So follow along, we'll be building this, all of the mechanical components of this in this video, and then we'll start on the proper robot arm build in episode 4. To build the Servo Gripper Kit mechanically, we'll be using the AR4 Servo Gripper Kit bag, which is purchased separate to the arm and referring to pages 265 onward of the build manual. We also in here get various electrical and mechanical components, including screws required for assembling this, and a 25 kilogram servo motor. There's also the Arduino Nano board in here, an expansion board and power supply. We also have these various 3D printed parts. This one is the AR4 SG1 or Servo Gripper 1 base, printed 100% out of ASA carbon fiber rather than PETG. We have the AR4 SG1 Carriage, again printed with 100% infill out of ASA carbon fiber for its strength and dimensional stability. And we have the center bar here, which has got a hole in the center and 2 small holes on the side. We also have the gear for the pinion and 2 sets of jaws for the rack and pinion jaw mechanism. These were printed out of polycarbonate, both for their strength and for their wear resistance, given that they'll continuously be running up and down the gear. Not in front of me is the auxiliary enclosure and the fan cover, etc., all of which are more electrical in nature, and we'll get building on those in a future video. So the first process will be on page 286 of the build manual, which calls for this to be tapped, for 4 of these bottom holes to be tapped. I've personally found that the screws are almost self-tapping into the plastic, and you get much better adhesion of this adapter here to the part, so long as you print it with good dimensional accuracy. So what is actually better is to go through this with like a 2mm drill bit and just make sure that any build material has been cleared out of the pilot hole. So just using a standard drill and a 2mm drill bit, just drilling through these end holes here to make sure that there's no build material left over. That's going to impede our pilot hole. We can also use a 2.5mm drill bit to drill out some of these holes in here. However, with this being printed on a bamboo printer, these holes are very dimensionally accurate. And again, the screws that are used in here will self-thread into the plastic. So these are all part of the Servo Gripper Kit, and we'll take out the parts that we're going to use today, which are these 2 75mm long linear rods and a number of mounting screws. There will also be inside this little bag a 16.5mm stainless steel rod, which we'll be pressing into the carriage next. So we'll empty all of these out. There should be 14 of these type number 6 thread screws and 4 of these M3x10 pan head screws. So we're not going to tap these, and we'll leave these holes for now. If we have issues screwing it together, we can obviously chase out the holes with a 2.5mm drill bit as called for in the build manual. So the next thing is to actually get the servo itself. And mount it so that the larger block here on the right hand side of the base is the side furthest away from where the pinion is on the servo motor. So this will press down like that, and we can see that there's the 4 mounting holes for the servo motor. Using some of these number 6 threaded screws, we'll mount this physically into the 3D printed component. And as mentioned, it will just screw in place. No need to chase out the holes with the drill bit unless you've got bad dimensional accuracy with your 3D printed parts. So really comes down to you. I personally wouldn't tap the holes or drill them out first. Rather try and use the screws, and if you have issues with that, then go back and chase out the holes a little bit with that 2.5mm drill bit. So that's the servo mounted there. We're now going to go to this carriage here, and we need to find a 3mm drill bit. So this one here. So we'll take our 16.5mm or 16.5mm long shaft and press it into place in our 3D print, making sure that it's flush with the bottom of our 3D printed part. So when it's flush with the base, that's when you know that the shaft is securely in position. And while it's meant to be super glued, there really isn't much ability for this shaft. There really isn't much ability for this shaft to move side to side or up and down once it's all assembled. So then with this AR4 carriage, put it over the top of our base, and there's only really one way that this can line up, the screw holes going through, and we'll need 6 of the number 6 screws to screw this down into the base. Now, the build manual also says that we should be using a 3.1mm drill bit to drill out the center bar and the gear, or to drill out the 3D printed gear here, which is printed with polycarbonate. However, I've personally found that it's nigh on impossible to find a 3.1mm drill bit unless you go to specialty hardware stores here in Australia. So we'll be using a 3.2mm drill bit, which seems to be a lot more common. And obviously, if you've got a drill press, try and use a drill press, you'll get a much nicer hole than just using a hand drill. And by doing this, the gear now slides over that center shaft. And spins quite freely. We can also at this point see that all of the screws are recessed. The AR4 embossed into the 3D print sits where the back of the servo motor is. And this is how the gears will actually sit in the gripper assembly, like that, sliding forward and backward along two linear rods so that they open and close like so. At this point, it's worth checking that this mechanism's kind of working and seeing whether or not there's any small parts of the 3D print that are interfering with others. So there's a small section here where there's still some build material, and that's going to cause us grief as we go to put this assembly together. We'll also at this point install the center bar. I'm going to drill this out to 3.2 mil, which of course means that the shaft in the center can turn, but once again, it'd be difficult for the shaft to move, to leave the assembly, and we can always put a little bit of Loctite in there. It'll just give it a little bit more freedom to still easily rotate in the printed assembly, given the tolerances that we have. So I'm going to screw this down, not too tight, but enough that the edges still flush with the rest of the carriage part. And you'll see that on the side there, that as we tighten this up, it will go down until the gap's very small. Checking that the pinion gear is still rotating easily. And then we're going to take our drill bit, which is 3.2 millimeters, as mentioned, holding our parts with some pliers, not too tight because we don't want to scuff up the edges. We're going to drill this, drill through the holes that were printed to give ourselves our 3.2 millimeter guide rail holes. Once we've done that, we can put the rods through and make sure that the part easily slides on the rods. So doing that through each hole and with each of the jaw components. Quickly tip this upside down, make sure that we blow out any plastic that's gone in there. And now we'll install these jaws like so, sitting over the center rail. And if you hear any interference or you hear it kind of slide or snap into place, there might be a need to clean out a little bit more material from the center of these pieces, because they're most likely catching on the center rail. So whether you use a small knife like I'm doing here, or you use some sandpaper, just removing a little bit of the build material, the 3D printed material, to hold the pieces onto the center rail without too much friction, is really what we're trying to go for. And you'll see that these now move forward and backwards in the assembly on the center rail. So we can now slide our rods into the end, and we'll just use a 3 millimeter drill bit because we do want a bit of a press fit here. we'll use a 3mm drill bit to drill into the end of these rods. And should be able to press the rods into place and watch them go into the part. Does help sometimes pressing down onto a hard surface, obviously not trying to damage the bench. And there we have the rails installed. Now at this point, if there's a fair amount of friction at play, it could mean that the rails are slightly bent or that the part doesn't have a lot of clearance. So one of the easiest things to do is to go back into your part with the end of some pliers or something else and just push the rod out a little bit on the end. Grab it with the pliers and use some leverage to pull the rod out of the carriage. It is quite difficult to do, and even though the build manual says to super glue this, I would not do so until you've tested that the parts easily slide along the rod. And there we go. You can see that coming out. And we can go and open up these end holes a little bit to give it a little bit more play. Obviously the tolerances are quite close in this whole assembly. So just using that 3.2mm drill bit, chase out these holes a little bit. And really the troubleshooting can be done by putting these jaws back in without the rods in place and then seeing whether or not they easily move. And if these jaws easily move along the center bar and with the rack and pinion without the rods in place, then effectively it's telling you that the rods are bent or need to be given a little bit more tolerance. So once again, cleaning up some of the 3D printed parts does help in this process. But we'll get these rods and just push them through. And we can see now that it is moving, just with a little bit of friction still. So we might take these rods out and just chase out the jaws a little bit to give it some movement. You don't want to chase out these holes too much, obviously, because you want a high degree of accuracy in what we're doing. But this won't work unless we have some easy movement of these parts. And we can see that we've got some movement happening. So with that, we can play around with that a little bit before gluing the rods into place, and a little bit of sanding doesn't go astray either. So we'll just press press these rods into place. And see that we can actually move these backwards and forwards. So a bit of effort involved in there, but it will actually move. So we'll play around with that a little bit to optimize it, but that's the actual mechanical build of that. And the final component is to take the J6 adapter plate, make sure that the key up the top is pointing towards the back of the servo motor. And then while we've got all of this here, line up the holes and use these little M3x10 pan head screws, which will screw into the 3D printed part. So we'll go ahead and finish up mounting all of these screws. But there you've got the AR4 Servo Gripper Kit with our moving jaws that just need a little bit of fine tuning with the rods prior to super gluing. Thanks for watching, and I'll catch you in the next episode.